For large applications like Magento, Shopware, or those based on Symfony or Laravel, autoloading can accidentally become a huge bottleneck, and I regularly see it taking more than 100 milliseconds because developers made one of those following mistakes that we will tackle one by one in this video. Moin, my name is Benjamin and I work on PHP performance topics for the last 10 years, helping thousands of developers, companies and open source projects along the way. Let's summarize quickly what we mean by autoloading performance and how it differentiates from compile performance and integrates with OPcache. PHP runs a script that references a class that has not been loaded yet, like in this example here, the user create. It triggers the autoloading subsystem. The autoloading subsystem then calls all registered callbacks. For example, in this case, we registered one callback. The callback receives the class name as an argument, and then it's the responsibility of the callback to load the class. Here we have the user class, and it's loaded dynamically. And then if we run the script, autoload example, we see that the user class is available and we can var dump it. Multiple autoloaders can be registered using SPL autoload register, and then they are iterated in the order they have been registered, and they each can try to load the class. If we have, if the class is not available, like in this example where we load a customer, we output the potential path, we check that it exists. In our case, it doesn't exist. Then we can see that PHP throws an error that the class was not found, even though the autoloading mechanism was triggered. It's important here that the file exists is there, because if we don't have that function, then PHP will already run into an error that it cannot load the class of the path here. Looking at an execution flow through a call graph, we can see for this example that when autoload example PHP gets executed, the engine triggers autoloading, which the profiler can hook into and tracks as a generic autoloading node, which then calls our registered closure callback that we passed into autoload register and then successfully runs user create. Our class should be loaded from a file is standardized through the PHP framework interoperability group PHP-FIG in their standard recommendations PSR 0 and PSR 4. Summarized, the beginning of the namespace points to a directory, either a project or a vendor library, and then the rest of the class name is mapped to subdirectories of this pointer. The class name itself is then the file name in that directory. See in our example project where we have a composer-based autoloading as well, we load the vendor autoload PHP file. This is generated when we call composer dump autoload, or automatically composer install and upgrade also call this. Then this generates the vendor directory with the autoload file. And in our case, we load the namespace example from the source subdirectory. We see here we have the post object from the example namespace. And in our composer example, we load this here, and if we run this, we see it works, dumping the file to the screen. For each class that is autoloaded, the PHP engine spends time in two layers. The autoloading layer, which we saw here with our callback, and then the OPcache layer, loading either compiling files that are not cached yet or loading them directly from memory. In this video, we want to look at just the autoloading part of the performance. Now that we know the basics, we can look into 5 mistakes that you can make to hurt your application performance when dealing with autoloading. But before we get to it, if you like to stay informed about PHP performance topics, I would like to ask you to subscribe to our YouTube channel or to our newsletter. The link is below in the description. The first mistake is not using a class map based autoloader that pre-computes the file of class name to file mappings. So at the deployment time of the application, you can already scan for all the classes in your application and see in which file they are present. And then you could generate an array that points from class name to a file directly. This is a very performant optimization of autoloading because it makes the autoloading time, so the PHP script the time, very minimal. You only need to look up the file name for the class, and then you can immediately call require or include and go to the OPcache performance part of autoloading, which when you use OPcache also takes no to little time. Composer already includes this class map based optimization, and you can run composer dump autoload -- optimize, which will generate an optimized version of the autoloader. And you can see that in the dumped files here, where it includes the class map of all the files, and that is used for the lookup. Without a class map, the computation for class to file has to be done in every request over and over again. And most importantly, the autoloader also has to do a file exists call to check that the file really exists at that point. And this is usually the expensive part that you can skip with the class map autoloader. Let's quickly look at the class loading code from Composer. So the class loader is generated into the vendor directory, and we look for the load class function, which is the autoloading callback. It calls the find file function and then includes the file. So find file here, you can see an early exit if the file is found in the class map. So this is sort of the high performance path for dump autoloading. If that's not called, then we find file with extension, and this one is more expensive. As we can see here, it iterates over sort of different things, and at the end it needs to do the expensive file exists call. Bonus performance advice: if you're generating a lot of classes during deployment, for example in Magento 2, the AOP interceptors or Symfony and Doctrine proxies, then you can run dump autoload after the generation to make sure that they are included in the class map and also getting the performance improvement for those generated classes. The second mistake is loading unused classes in every request. Dependency injection pattern might create an object graph with a lot of dependencies, very deep, of objects that are not used in the request, but they still trigger the autoloading stack, and if the autoloader code itself is a little bit slower, then this performance hit is felt in every request, even though the classes are not used. This happens usually, for example, for event dispatching patterns or controller patterns or commands in the console. All of these classes could be loaded completely into memory, even though they are not used, and then all their dependencies are loaded as well. An example how to tackle this problem is the Symfony event dispatcher that works around it. So theoretically, you could register events for or listeners for any kind of event happening in any kind of part of the system. And loading them all into memory in every request is wasteful. You really only need to load those listeners into memory that are needed for events that are triggered just in this single request. So let's see how Symfony tackles this problem. So when we have an event listener, we can register the listener either directly and triggering the autoloader here, or we can wrap it in a simple closure that is called only when this event is actually triggered. So I've made a simple example here with a listener class, and this listener has a dependency, a reference to an expensive dependency. The expensive dependency is doing a sleep call in its constructor. So the way this would work out in this case here, we trigger for a completely different event that doesn't have any listeners. So time the event dispatcher, it takes more than 1 second because the expensive dependency was loaded. But if we comment out this code here and we call it using this wrapper closure, then this is never called, the autoloading is never triggered, and the performance is much faster. With PHP 8.4, there's also native lazy loading, which will help greatly with this problem in dependency injection containers, and I've made a few videos on this channel that show how. The third mistake is expensive prepend autoloaders. The class-based autoloader of Composer should, in my opinion, always run first, because it will statistically have a very high success rate of finding a class. Let's say 95% of classes will be in the class map, and then all classes that are not in the class map are led through to other autoloaders. From my perspective, this is better than prepending special or like expensive autoloaders before Composer, and then making the Composer autoloader authoritative, which means that Composer throws an error if it doesn't find a class. A few years ago, we saw this ourselves in the Tideways backend application. On our high volume, high throughput endpoint, we saw after a deployment the autoloading performance here shown in the tooltip as a black box and the chart going up from 1 millisecond to 3 milliseconds. After investigating, we found the culprit here to be the Laminas framework. And they migrated from the Zen framework namespace to Laminas, and they included a special autoloader that worked with class aliases to make this migration more smooth. This was done by a Laminas Zen framework bridge package, which shipped this autoloader. And the README of this package clearly states that it should only be used if you're doing this kind of migration. We didn't do that, we just used the Laminas namespace code directly. However, the Laminas event dispatcher package, which was pulled in as a dependency for us, also included a reference to the bridge, and then it included the autoloader, causing this performance hit. If you need this kind of special autoloader, then you should be very careful to build it in a way that it runs after the Composer autoloader, and maybe even qualify it to check for the namespace first before doing the expensive work. In our case, the special autoloader caused the 2 milliseconds additional loading time to this already super fast endpoint. If external dependencies mess with the autoload order in the way we saw before, then this is no problem. You can use SPL autoload functions to get access to a list of all the registered callbacks. Then you can deregister them and just re-register them in the better order for your performance requirements. The fourth mistake is building your own preloading code. A few years ago, when autoloading was still a hot mess in PHP before Composer came around, there were various performance improvements that libraries suggested that you should do to improve autoloading performance. At that time, autoloaders were usually super expensive because they had a lot of special code in them, many ifs and here and do this and do that. Every library had their own autoloader, so you need to iterate over 10, 15 different autoloaders in your code, and this was really expensive. My own experience with this pattern was formed during my time working on Doctrine 1 as an open source maintainer. We had a script to compile Doctrine into a single very big file containing all the different classes in one file, so that you only needed to require once this file at the beginning of your script and then never had to deal with the expensive autoloading part of Doctrine. The problem with this was that loading one very big file with a lot of classes that you don't use in the request is actually very expensive. Over time, open source libraries realized this and removed all this kind of code, relying on Composer instead. So Symfony, for example, pre-compiled some code before, which it's not doing anymore, or more efficiently using the dependency container. And so if you have this kind of code in your own project, requiring a lot of code upfront, and doing this in every request, then I would advise you to not do that and rely on the class map dumped autoloader of Composer instead. Not using OPcache preloading is the fifth mistake you can make, but honestly, this only affects a small subset of people where the application is running very fast, below 100 milliseconds. And using OPcache preloading, which is built into PHP, you can skip the autoloading stack completely and saving like 5 to 10% of those fast requests, giving you a small additional edge. As you can see, bad autoloading performance is not a problem that is solved for you out of the box. Even with Composer in 2025, you can royally screw up autoloading performance by making a few mistakes. And it is necessary to look into this and understand it better to get the most out of it. If you want to learn more about PHP performance, there's a video on OPcache preloading on this channel, and there are also many more about different topics. Please subscribe to our channel for more performance topics or to our newsletter. The link is in the description. Bye!